But again, for everyone who has joined, again, a big welcome. Um, the goal of this talk is to talk about annotation as what I consider to be a system engineering problem. So, whenever we are working, especially within the realm of visual AI, annotation is called ground truth for a reason, right? The performance of the models we build or the models we fine tune, or ultimately the applications we build, regardless of the domain, is depending on the accuracy of ground truth labels. Um, there are a couple costs to that. Cost number one is that annotation and labeling correctly is expensive, especially the more that your industry relies on, domain expertise. Think the medical fields, high expertise industrial fields, but really any kind of field in which like knowing your stuff matters, right? Um, on the other side, we've learned that there are strategies to ensuring that the data you annotate is neither spurious, right? You're not labeling what doesn't need labeling, but also you're not failing to handle the edge cases, right? That'll cause your model to have failure modes. So when I talk about annotation as a system engineering problem, it's trying to reduce the bottleneck of labeling being what holds your models back. And that includes improvements from both a workflow perspective and a number of samples you label and where they come from perspective. So what we're going to do is we're going to organize this talk into what I would consider to be like four pillars of the workflows of building computer vision applications. And we'll call those curate, annotate, review, and evaluate. And the framework for attacking this problem is going to be the 51 software application. So if you have kind of a platform that you can use to not only annotate your data, but also perform all the necessary logistical work around it, then that makes your life a lot easier, right? You're not gluing together integrations. You can have sets of users that exist in a common set of roles and accessibility to that platform. So I'm going to talk about what I would call like theory and practice here, especially in the slides. But where I want to actually start is I want to kind of start with kind of an initial 5-minute tour of what I'm talking about when I'm talking about the 51 platform. So 51 is a multimodal data platform for physical AI, visual AI. It also supports audio. It supports modalities such as LiDAR, images, video, 3D, geodata, all sorts of different domains from industry to AV to medicine to manufacturing defect detection to agriculture. And the idea here is we can sort of think of it as I like to use the term it's like the IDE or like just like we have dev tools for the software development lifecycle. This is the platform for the computer vision model uh, training, evaluation, and deployment lifecycle using kind of the opinionated approach that data quality is ultimately what matters in terms of your model performance. So where I actually want to start off is I want to immediately hop over to here. And here I have a manufacturing data set in 51. I have several different classes of manufacturing objects that are all distributed here in the embedding space. And if I'm just qualitatively looking at the embedding space, I am seeing that there might be some outliers. So for example, in this red area, I notice that this corresponds to metal nuts, right? In this class of objects. And then I see that there's sort of these outliers over here that I can lasso. And if I lasso those outliers, we can see that, okay, there's something about these that makes these outliers. So that these might be items of interest that I want to send to my labelers to make sure that there is proper edge detection here. Give me 1 second here. There we go. So I might go in to this annotate section and create a new workflow. And actually, sorry, before I do that, let me go back here. I forgot to create a saved view out of this. So let me take this view here, this collection of samples, and I might say, hey, this is something I want to save. So I'll create a saved view, and I might call it, very creatively, metal nut review, or I might, create it separately. I might call it outliers need labeling, right? I know that just purely through qualitative analysis here of the embedding space, these are some things I want my labelers to pay attention to. So then over here, I'll go into the Annotate tab, and then I might create a new workflow, right? I might give it a name, and then you can start with a blank canvas. Ultimately, I am going to create kind of a predefined workflow that is kind of the typical flow of we'll start with samples that'll provide as input. Labelers will go in and annotate. They'll be marked for review. They can either be accepted or rejected and sent back to the annotators. And then once we go through, the necessary iterations, they're sent to final review and then maybe accepted. If I go through and then start the workflow, what then ends up getting created are a set of tasks. Whoops. Looks like the workflow still starting. We'll give it a second here. Yep, there's a set of tasks given to the annotators. Oops, sorry, I forgot to create it off the saved view. Let me do that real quick. Let me create a new workflow. Sorry, annotate outliers. So here I originally created the workflow off the entire sample, but let me actually create it off of the saved view that I created. So outliers need labeling. And then now I'll start the workflow. And then now if I go here and I look at my task, right, we see the 23 samples in that view that need labeling. From here, I can then go in, and then it immediately launches into a labeling process. And kind of where I'm going with this is this can become an iterative loop. Now, this is a very basic example of labeling here that I could do, right? This anomaly detection data set is ultimately binary classification. Either it's an anomaly or it's not an anomaly. So if I go to this Annotate tab here and I look at my schema, ultimately as a labeler, I could decide, okay, either it's the anomaly is either true or false. In like imminently here in like 30 seconds, I'll show you how it can get more complicated than that. But purely in terms of annotation workflow, I might say, okay, maybe, I don't know, this is not an anomaly, submit. This is an anomaly, I'll leave it at that, submit. Maybe I decide this is not an anomaly, submit. And then as I go through, we can see that some of these are being marked as labeled. Now, when it comes to actually choosing, when it comes to actually modalities and ways that we can label our data, 51 supports a whole lot. So purely in that Annotate tab here a moment ago, I showed that, okay, binary classification. But there's a whole lot of others. For example, there's video data sets, right? And tracking labels that you can use. There's what we call, whoops, let me log back in here. There's what we call grouped automotive data sets that allow us to view the 3D point clouds alongside the image frames that we're labeling, right? So if I select these, let me go back out here, right? We can see off to the side, here's what's being selected. And as an annotator, I can compare back and forth. We support geospatial data, right? Aligning labeling metadata with the location that those items are in. We support segmentation, right? Both image frames and in this case, consolidated into video. We have a neat new feature called click to segment. And what that allows us to do is it allows us to use foundation models to, based off of a class, segment, in this case, maybe an individual plant. Let's see if this works for, or the entire, soil around it, right? And then also use traditional methods like brush and so forth. We support even more than that. So this I'm kind of cheating a little bit with the GIF, but just to kind of show you the full array of things from the annotation side, we have the flexibility to, click to segment, we perform individual segmentations, change bounding boxes. Fundamentally, the annotation modalities are fairly rich here, and it largely stems from the modality within the 51 platform itself. Now, just a couple quick notes. So here we see 3D polylines, for example. Okay, so let's say the annotators go through their flow. So let me go back here to my flow here, right? Regardless of the annotation type, we created a flow, and now we have a few labels. As these are marked labeled, if we go back into the annotate flow, we can see they are actually sent to this first review. So notice annotation is still in progress. Now we have this first review task. And now the reviewer can go in and they can start to perform their analysis of the labels, right? So again, in this case, it's fairly simple. It's anomaly or not an anomaly. If it was something more profound like, a detection mask. So this is an example of actually a flipped um, metal nut. So here the entire thing is masked because it's actually flipped over, but it could something that could cause the reviewer to give pause. They can choose to reject or approve the label. If they choose to approve it, it gets marked as approved and it's not sent back to the annotator. Instead it moves forward. If they choose to reject it, like I might do with this one, and maybe this one as well, it does get sent back. So if I then go back to my, whoops, sorry, if I go back to my project management pane here, we can see that, let me refresh. Should have been sent back to the annotator here. Let me go back here for a moment. Let me reject this one as well. I think I may have gone back and forth between what I rejected and approved, but I've gone through all the samples and ultimately we see right. Let me see. Let me look at my workflow here. It should have gone back to the annotators here. I don't know why it didn't do that. First review. Rejected. Final review. Accept. 0 left. Is there anything back to label here? Okay. Oh, yes, I'm sorry. Yes, so the ones I rejected did get sent back, right? So here we can see, yes, see, we see the rejected here, and then as an annotator, I can go back. And then here in the discussion field, I can also add comments, right? Either from the reviewer side or the annotator side as to why it was rejected and just have comments associated with the labels. Okay. One last item as well here, and again, this is something I'll talk in a little bit more detail about, is from a structural standpoint, where we have this concept called ontologies. And the idea of an ontology is you can add attributes or metadata for how your labels should be added, right? So for example, I'll go to a slightly different data set here. Let me give me 1 second here. Here, this is an AV data set. Within this ontology, I have an set of attributes I can create called new scenes attributes. And notice those attributes create metadata like occlusion, the number of doors on the vehicle state, the pedestrian pose, right? So this creates a schema of items that can be part of the labeling process for labelers to be part of their guidelines for labeling, right? Okay. So I wanted to kind of start there as just an initial like overview of the importance, right, of having this sort of workflow path of within a single platform having both the curation requirements, the label project management requirements, um, and the necessity of having an iterative loop between labelers and reviewers. There's a couple things that I deliberately didn't talk about yet. One of them are like model assisted labeling. As a little bit of a teaser, we'll talk about that in about 15 minutes, but I just wanted to set the stage here at the beginning before we ultimately talk about some of the theory behind the practice we're going for. Now, I saw that there was a question here in chat. Just a couple things to mention here. Um, First of all, 51 can be accessed in one of a couple ways. Way number one is there is an open source library that you can just download using pip install, literally pip install 51. That's very much intended to be single user local laptops. If you are a hobbyist or a student poking around, all of your data lives locally, literally in a directory on your laptop, both the data and the metadata. There's a local MongoDB that's bundled in as well. It's meant for single user, local install. The multi-user project management that I discussed and some of the more especially compute intensive labeling methods are 51 Enterprise. So 51 Enterprise is, a broader deployment that you would deploy into your organization's environment. It lives across, it lives across a container infrastructure. There's normally connected an external Mongo database. There's connected GPU orchestrators you would use. So it is more of a, multi-user deployment in that case. Okay. So I now want to use this opportunity to talk a little bit about theory. Um, and it has to do with both labels, label quality, and the number of labels. So if your ground truth is wrong, that'll ultimately cap your model performance. And especially when label errors are clustered by a particular slice of your data, maybe a weather pattern, if it's like AV data, maybe it's soil type, if it's agricultural data. Ultimately, that'll skew, your model's performance and obviously your model's performance with um, respect to a particular slice. And fine tuning off of that right will just like continually reincorporating noise into your model. And moreover, more labels won't average out a systematic error, right? If there's a failure mode in terms of your ground truth or how your labelers are approaching certain slices of your data, right? Just simply labeling more of that data won't help. And this is actually based off some survey research that has been done here at Voxel 51, where ultimately, 1 in 3 teams say that over half their annotated data never reaches production, right? Basically, we're caught in a loop of annotating and labeling more and more and more data without making structural improvements to what categories of data we're labeling and how we're addressing particularly things like rare cases. So it's not just ensuring that data is labeled at velocity. It's not even ensuring that individual samples are labeled correctly, even though that's very important. It's ensuring the right data is getting labeled correctly. And that actually moves us way upstream into what we call the data curation layer. That is, are we ensuring that we're choosing the right data to be labeled in the first place? So remember in that like 5 minute that ended up being a 10-minute demo here a few minutes ago, remember that I started it was I maybe hand waved it a bit, but I actually started by like having these embeddings and directly lassoing the section that I realized probably should be reviewed and that I cluster together as a labeling batch. So what that ultimately means is that in order to maintain labeling velocity while also baking in like the systematic intelligence of labeling the right data, we need to create a better curation, annotation, review, and evaluation loop where each stage is intelligently handing that slice off to the next stage. Again, I started a labeling run with a particular view. I handed it off to a set of labelers. They labeled, they then reviewed it, they approved and rejected samples, which then got sent back. Now, therefore, this becomes, again, somewhat of a linear flow. Some of it can be nonlinear, but then we can start to identify bottlenecks, right? Like, what is curation our bottleneck? We just don't understand our data set and what subsets we should select for labeling. Is it annotation? Like, are our annotators slow, or are they not labeling data correctly? Or is it reevaluate, or is it evaluation, right? Do we have trouble ensuring that we're identifying model failure modes with respect to the segments of data that are problematic and causing the model to fail? And a lot of this, if we look at the curation side, goes back to the idea of uniform sampling underrepresenting long tail cases. So the typical example of this, right, in like the automotive space would be like I don't know, pedestrians walking across a crosswalk in rainy conditions, right? Capturing those long tail cases that are not the norm are critical, especially in safety critical scenarios. As a quick aside, I went to school, I did my undergrad and grad education in Pittsburgh. And Pittsburgh famously was where Uber started, around 2014, 2015, started testing a lot of their self-driving cars because the city is famously like not a grid, right? It's hills, it's hairpin turns that are treated as normal turns. There's, blind turns all over the place, blind driveways. Uh, Terrible, weather that's all over the place. So that's was considered, hey, the place where we should gather our data. Even once the data is gathered, though, there's a matter of actually needing the right samples and identifying them, which we'll talk a little bit about here in a second. So having the right data is essential so we can ultimately train that data. So first, we need to select for coverage and uncertainty and be intelligent in our data selection. So this can be done in both qualitative and quantitative ways or a mix of the two. So for example, I brought up the idea of embeddings a moment ago. Now on the right is a 51 feature that is called patch labels. So in my example earlier, we saw the MV Tech data set, which is an industrial data set. And that one was pretty straightforward, right? It was like a single detection because you just have a camera over a sample. But in data sets that have multiple objects or multiple attributes that are being labeled, it might be important to zoom in on that attribute one at a time. So I'm deliberately zoomed in here to this little graphic. But what I ultimately ran is there's a button that you can run called two patches that creates a single sample view of each patch zoomed in on that sample. And what I've done is I've rendered the embedding space based off that patch view and then grabbed maybe a section here in the corner that's kind of looks a little bit different, right? It's these rainy conditions that like aren't part of the overall cluster of data. And we can see here that's because like there's like blurry, glary raindrops, right? That are kind of making it difficult to know what we're talking about. But if we're relying especially on like camera data, that's critically important, right? It needs to be able to at least have some part of its training set that has that sort of data. What we can also do is we can rank cases based off tools like similarity and uncertainty. So there are 51 methods called uniqueness and similarity scores that you can compute based off the embeddings indices that allow you to then rank and then sort your labels and establish views of perhaps the most unique samples, but also samples that might, follow that samples that might be similar to another sample. And then lastly, if you start to um, incorporate things like vector indices and things that allow you to like query by natural language, then you can be a lot more curative in your approach and start saying like, hey, I want to search for all cyclists at dusks. Where I'll get into in just a little bit is you can start to combine that with the labeling process itself. We're introducing a feature called the agentic labeler that is taking foundation models and then training an agent based off prompts. So you can take your model, you can add in a prompt, you can select existing positive or negative samples with respect to that prompt. You can run that prompt on separate test samples and then use that to initiate a run on new data and then continually train your agent based off of that. More on that in just a little bit. Okay, so I said qualitative and quantitative methods. Another quantitative method that is based off some research done by the machine learning team at Voxel 51 is a method called zero set core set selection. So this is a method. You'll receive this paper in the follow-up email. If you want to kind of grab this reference here, feel free to look up the full paper. Ultimately, what this does is it takes unlabeled data and scores each sample based on how much coverage it adds versus how redundant it is. Think of it as somewhat of kind of a fancy way of computing uniqueness. And the goal is to keep the high importance samples. The idea is to basically take, based off an initial selection, the initial samples that need labeling, but then later you can, rerun Z-core and then add additional samples later. In fact, I believe it's in here. Um, we actually have it as an optional plugin. So this is just, it's a Python script you can run, but you can also run zcore as a plugin here within the UI. And that literally creates a zcore field that'll have, the score assigned to that sample. And then you can sort samples based off that score and collect the labels needed uh, to annotate off of. So one example is on a robot data set this was tested on. It cut around 95% of the data while maintaining diversity. Okay. So kind of one takeaway that we had here is we found examples where, informed selection can reach around the same model quality with 60 to 80% less data. And again, this is sort of like, kind of a number that I, fully understand can breed some skepticism. It fully depends on a lot of ways on the benchmark. But the goal is, introducing intelligent ways of selecting data is better than just throwing unlabeled data from, a data lake at your labelers. Okay, so now's the fun part, right? The workflow I talked about so far is based off of human labeling. We now know that foundation models have become good enough where they can be a very solid first pass at adding labels to our data sets. Again, humans still need to be in the loop, but labeling everything by hand is slow and uneven. Moreover, we can also take advantage of if we create maybe a slightly lower confidence threshold in our models that we use, we can maximize recall. And anyone who's labeled data before knows that it's generally easier to root out false positives than false negatives, right? False negatives are a needle in the haystack problem, but with false positives, you can, see that label there and like delete it if needed. Moreover, if you use a model to do your initial pass at labels, that gives you things like confidence scores and other metrics you can do to use other algorithms to suggest whether the ground truth is correct or wrong. So aside from confidence scores, you can take a model that did the initial labeling, take and compare it to human annotated ground truth and suggest that, okay, based off where the model agrees and where does it disagree, is there human ground truth that might be wrong just to some, schematic or kind of paradigm issue with the labeling. Um, so one of these features that I want to introduce here is the agentic labeler. It's a panel in the 51 app. Under the hood, it's ultimately just a vision language model. But the idea is you give it some context needed and a few examples, and then you can save it as an agent that you can then initiate a run on. So if I go to this here I have here I have a data set that is a fairly simple hard hat detection data set, right? It's a set of construction workers. Think of it as like a safety relevant data set. Some are wearing safety equipment, some aren't. I want to train a model that can detect, when someone is not wearing a hard hat. So here I've trained this agent and I've given it context, right? The context I've given it is, whoops, sorry about that, is find site workers not wearing hard hats, right? That's the text prompt. And then I'm saying it's detections. And then I've created a class. Again, this is going to be a binary object detection here, just no hard hat. And then I've given it positive and negative examples. Now, this is kind of a double negative, right? Because the class is called no hard hat. So positive examples are people not wearing their hard hats that I've added from the grid. And then negative examples are people wearing their hard hats, which you can kind of see if you zoom in there. And then what I can do is I can choose items, run a test on it, and see how the agent performs. Now, because I just have a single class here, it might take, a little, it might act in kind of an interesting way. For example, if there are no hard hats, right, it might just say, hey, there's nothing to label. And I'm also realizing that I think my GPU, I think I just have attached CPUs here. Yeah, there we go, right? So for example, in this one, it's like, hey, did not find any people not wearing hard hats, but it found these examples, where it's bareheaded people, right? So the idea, and then I could say, hey, I want to offload it to this field that I'm calling predictions. So that is the agent itself. And then once the agent is saved, then you can initiate a run that actually populates the prediction field, right? So here in this example, I actually did the run already. it created this field called predictions when it ran. And right here we see that, yeah, right, we have people with no hard hats, right? And ultimately, right, the human isn't out of the loop, right? It's ultimately for us to decide that, okay, is this a relevant example, right? Like, is this a relevant construction site that contains these like no hard hat people, right? Or is this something that's kind of a long enough tail where, hey, this is like people standing in a parking lot wearing suits. These aren't the sort of personnel that's going to be most relevant, right? That's ultimately something for you to decide in your data selection and as you kind of iteratively train your model. All right. Okay. So just as a couple notes here, Um, there are a couple layers to this. So again, there's this agentic labeler. We also have a feature called auto labeling, which is a separate panel. So if I actually go to this automotive data set here and I open auto labeling, this is, whoops, sorry, wrong data set. This is labeling without like the agent context, right? So this is still using a VLM to label, but it's a little more like manually toggled where you're selecting your samples, whatever it might be. You're not training a new agent, but rather you are choosing, an existing fixed or open vocab model. You choose the model, you actually choose the size as well. You define your classes if it's zero shot. You set a confidence score. So it's another, I don't want to say more manual route because it's still using like, the inference of a vision language model. But ultimately, you're specifying just purely based off that VLM, what your classes are, what you're labeling kind of more directly along with the minimum confidence score. So again, that works for first pass labels as well. Okay. So from there, we can start to what I call, work with the very technical term called the kink in the hose, right? When it comes to systems engineering problems, right? So when it comes to labeling velocity, for example, we can track things like progress and speed and quality because we're all in the same platform. Something really important that I'll bring up in more detail in just a little while is also the uh, idea of once you have a downstream model trained, right? Once we get not only to the aspect of label review, but also the evaluation side, we can also start to look at various scenarios of data slices and identify, okay, where is the slice of data maybe like foggy samples, for example, again, if it's like an auto data set that are causing problems, and then, redo a labeling run based off of that, redo a model, if assuming that, the data is the problem, start retraining models based off that particular slice. So wherever you are in the flow, the idea here is that you can kind of assess your progress based off that flow, like the number of samples, the number of labels, the time per sample, the time it takes per label. Importantly, right, like how often are we sending labels back to our annotators because they're being rejected in review. So here it's only about 10, here it's about 10%, right? With a 90% acceptance rate. And the hope is because we're using model drafting first, that first pass can run much faster, right? At minimum, it might be that a user is going through and like deleting labels that the model selected and maybe adjusting a few bounding boxes, but that they're not, again, doing the needle in the haystack approach where they're just, looking for objects in in a completely unlabeled sample. Okay, I now want to double click a little bit on the guidance aspect here. So when I did my initial kind of workflow here at the beginning, I said, hey, you can, initiate a workflow, and from there, you can create these schemas called ontologies. And these things are meant to work together, right? The idea is that the annotator doesn't have to guess what are the different attributes in the data set, that they are, have a label schema enforced upon them, and then the attributes of that schema can be customized through what we call ontologies. So, couple things to note, just basically how this gets set up. As I said before, if I go back to my, sorry, this is the wrong data set. Let me go. Let me actually go back to my other one here. Again, if I go back to my annotate pane here, right, the idea is at the workflow level, right, kind of the macro level, this UI is where you can set up workflows, right? So again, I could create a workflow here. Maybe it's an existing one, maybe it's a new one. Again, maybe annotate, data. I don't know, June 2026. Maybe it's like a new data dump that you're annotating. Again, you have some pre-made views you can do. You can also start with a blank canvas, right? And from there, create additional, streams and then start connecting these things together. Now, from a user management as well, I didn't mention this before, in multi user 51, you can also give permissions to who's allowed to access each stage. So for example, there's only like, a few users on this kind of demo instance I have up, but you can select who's allowed to annotate, for example, in the annotation one. And if it's the input one, sorry, let me actually go back to the review. Input doesn't really make sense. If I go back to this annotate outliers one, right? For annotate, I can choose who's allowed to annotate. This one's running, so I actually can't change it. Let me do one more, third time's the charm. This is the cost of doing things in real time. You can choose who your annotators are. They can be one or a group of selected people, or you can say anyone can annotate. You can choose separately who your reviewers are. You can edit the schema on the data set. So from the workflow management pane, I can edit the schema that's being used. Now, worth noting at the moment, ontology, so going back here, the ontology, so the additional attributes that you saw me apply earlier, the ontology structure itself is not UI surfaced yet. So like defining the ontology on its own and those attributes. So basically like here, the chosen ontology is AV detection, and that's where it has like number of vehicle doors and is it included or not included, and are there people in the vehicle and that kind of stuff, or what type of vehicle is it? The ontology can be applied in the UI as part of the dataset schema itself. There's still a programmatic aspect to how the ontology itself gets defined today. But then the workflow itself, again, can be created and managed in the UI. All right. And then again, the goal is to measure consistency against the workflows and schemas that we've created instead of assuming it, right? And then again, within each label, there is also like the discussion panel, which I briefly showed, right? When you're in that labeling pane and it's an assigned label to both an annotator or a reviewer, there's that discussion pane that where you can like, add information about like, why you labeled it the way you did or why you rejected it or just information about the sample. Okay. So going back to that, right? Within the workflow page where you're managing your annotation projects, you're ultimately given a task list. And when an annotator enters into the task list, right, they're stepping through the samples one by one. And then the reviewers then have their own task list where they can accept and reject, what's a label and what's not with a comment on why. So again, I'm actually going to go back here to, let's go to this one. Actually, sorry, this is in the wrong environment here. Let me just make sure. I'll go back to MVTech. Right. So let's say, actually, I'm going to start this workflow. So I'm going to kind of repeat this process here. It'll route the samples into the workflow. It'll then stage that workflow within 51. Here, I'm doing it on the entire data set. I didn't actually have to do that here. So I might give it a moment here. There we go. Again, we have all the samples here. And then as an annotator, as I am starting the labeling process, again, depending on what I'm doing here, like let's say I'm actually, instead of just anomaly, let's say that I am labeling segmentation masks. Or actually, let's say I'll just do detections here, actually, for example. So here I'll do predictions, annotate. And there's a couple ways I could do this, right? I could do a bounding box, right? Which is kind of silly here. Doesn't make a lot of sense. Here, if I do a segmentation mask, right, I might, again, this is kind of a weird example here. It's not going to be perfect, right? I might start to kind of do that, and maybe that's one. And I might do, yeah, it's not perfect. That's two. You get the idea. And then on this, again, there's this discussion field that I can comment where I might say, hey, scattered crack in bottle or something like that, right? And this becomes, a persistent threaded discussion for the reviewer. And then again, if I go back here to, oh, did I actually save it? I don't think I saved it. Whoops. Let me do that. Let me do that one more time. Yeah. Here's my discussion. Here's submit. Next one comes up, might do something similar, right? Yeah, I'll use the brush this time. Again, you get the idea. Submit next. So on and so forth. Again, this gets sent back to reviewers. They're marked as labeled. Again, now first review says, hey, 0 of 2 samples. And then the reviewer, those same 2 samples get surfaced for the reviewer, right? So the reviewer can look at it, be like, okay, maybe they'll say this one's okay. They can add their own discussion. Yeah. See what you mean. Approved. Looks good to me. Second one, I think I forgot to save this one. Maybe this one was submitted, right? Here's a good example. Submitted, but rejected. Hey, there is a crack on bottom. Look again. I'm just making something up here. And I might choose reject to reject that sample. If I go back here and then I exit out, right, we can see approved, rejected. Notice annotate circles back to only one out of the full sample annotated, right? Because one was approved, one was rejected. The sample that was rejected gets tossed back, right? And again, the discussion can continue. Again, I'm not sure why it's not showing here, but again, the annotator can continue. Right. Okay. What we can do also is we can leverage some of 51's built-in algorithms through a library called 51 Brain to surface, again, kind of quantitative ways that we can analyze our annotations in bulk. One of them is called mistakenness rankings. So this is, again, an algorithm that 51 has had for a while. And the idea is it compares model predictions to ground truth, but in a way that suggests that enough disagreement surfaces actual ground truth errors versus the model inherently being wrong, right? So it says, okay, where does the model agree with the ground truth? Based off previous agreement, there's cases of disagreement that suggest the actual ground truth is wrong. And that creates a field called mistakenness where you might say, okay, I might filter my data based off a mistakenness value of 0.9 or above. And this might be a set of samples that I save as a view and send back to my annotators for further labeling. right? The idea is, okay, I have this collection of samples. I don't know for sure that these labels are wrong or that this has incorrect detections, but the idea is they warrant further review. Worth noting, and this is back where that first pass of model assisted labeling can be very helpful, right? It catches incorrect labels, right? It doesn't catch missing labels. So coverage needs to be, handled separately. But this is again where if you do a first pass of model assisted labeling, maybe keep the confidence score, or confidence threshold like low to medium, maximize recall, then compute mistakenness based off a downstream model trained off the labels. Then you can start to, again, go back and see, okay, are these wrong labels or spurious labels, right? Ones that shouldn't be there at all, right? So an example we see here, just going back up here, if I just zoom in, you can hopefully see it. There is this box here that's on the hood, and this is a classic case of the ego vehicle being labeled. Another example is this like mount point on the windshield being labeled as well, right? These are good examples of things that, hey, this might be, a VLM might not be smart enough to fully know that that's not something it should be annotated. But if we send these to review, these labels just simply need to be deleted, which you can just delete with the delete button. All right. And again, the idea here is that once the labels are fixed and you're confident in your ground truth, then you can be more comfortable in analyzing slice-based model performance, right? So now that you're comfortable in your ground truth labels, we'll kind of talk about this here in a moment. Then that feeds into what we call scenario analysis, right? Model evaluation metrics, right, are all based off of assuming that ground truth is correct. Precision, recall, F1 score, slice-based metrics. The more confident you are in your ground truth, then you can start to do more of what we might call like, data focused AI, where okay, we're confident in our ground truth. Now it's a matter of improving our data set and what our model is being trained off of, and just addressing those edge cases and slices of data that we know are causing failure modes. Okay. And this, again, this is just saying what I just said, right? Fewer label errors are pushing our success towards actually focusing on true model errors. Um, Again, it's not going to fully erase the possibility of like label errors or label bias or again, coverage bias in your data set. But ultimately it gets us closer to like saying, okay, how do we now improve our model architecture or the data we're feeding into model training? All right. And again, this is, I think, an important bit. We're now measuring our model more honestly. Okay. And that moves us to the evaluation piece. So, um, remember kind of the four pillars I talked about are curate, annotate, review, evaluate. Curate, annotate, review, that was ensuring we have correct labels. I'm not going to go into like, the thing of making sure we have like training sets separate from evaluation set, avoiding leakage, all that stuff. I hope that's something that is sort of like understood um, among kind of your typical, machine learning best practices. But the idea here is let's say then we train a model, and then the goal is to evaluate it against our ground truth. Now, remember, once you go into evaluation, you're now making the assumption that your ground truth is correct. You want to keep it an iterative loop, right? The idea is, okay, don't inherently assume ground truth is correct. Always be correcting that. But when it comes to model evaluation, the math itself, right, is assuming that ground truth is correct when it comes to again precision, F1, recall, um, those types of scores. And what you can then do is you can evaluate model performance in a couple of different ways. You can evaluate it at the macro view, right? Whole data set performance. But 51 also includes a feature called scenario analysis that allows you to evaluate model performance with respect to individual slices. So let's look at both of them. So going back to, let's actually look here for a moment. Yes. Okay, so here, all a model evaluation here is it's taking an existing set of label predictions and evaluating their metrics against the ground truth. So here we have category specific predictions with a couple of different classifiers, patch core and PATM in this example. And then if I look at like the overall performance across all classes, that looks something like this, right? So here for a single model, here's our precision, recall F1. We can see class performance between normal and anomaly. Here we have a confusion matrix. Again, for example, here where it's confusing normal and anomaly, I can click on that and I can zero in on those specific samples, toothbrushes in this case, on where the model got confused, or at least, misclassified normals as anomalies. I can also compare runs side by side. So I have my ground truth. If I have another model, so let me do this. Let me go back to the metal nut example. I have a metal nut PATM model, and then we'll see, yeah, classifications for both. And let me kind of extend this out a little bit. Let me go back. Actually, let me reset my view here. All right. So let's do PATM and then patch core again. And here we can see, again, the raw metrics. We can see the side-by-side metrics. If we look at class performance, again, this is clickable. So I want to be like, okay, like normal was, quite good, just, barely a meaningful difference apart. Like that, I could click on it and like see what are those examples that the model was largely in agreement on, once this loads. And then anomaly, I could see, okay, the precision of, what are we at? Precision of patch core was higher for anomaly and then lower for PATM. And again, I can zero in on those samples as well. And then finally, likewise for the confusion matrix of that. Again, nothing too like crazy new here, but the idea is, again, with my data side by side, I can go in and see how these models behaved. And this is just another what I'll call qualitative example of the model looking at the data, yourself being able to kind of eyeball stuff, right? Like there's, again, there's quantitative methods we can use to suggest like model disagreement with ground truth. Does the ground truth disagree? But sometimes for visual data, like nothing beats actually going in and, you know, just examining it side by side in kind of a clickable, filterable way. So on top of that, and again, here I'm going to cheat a little bit here. I think it's easier if I just show this. This is showing another feature that, again, I'll kind of introduce in the UI here in a moment called scenario analysis. And it's fundamentally the same thing, right? You're still showing these core metrics side by side, and it's comparing multiple model runs side by side, but it's doing it on a slice specific basis, right? Based off filterable attributes. I kind of did that a moment ago. It was a little bit cheating because like these model runs were specific for a category in that manufacturing class. But when this GIF loops around here in a moment, what it's actually doing is we're creating a scenario, and the scenario is based off of like in this data set shown here, like weather patterns, right? So it's looking for like foggy daytime samples, right? So here it's clicking scenario analysis. Here we're creating a new scenario. We're giving it a name. We're selecting a sample field. And then from there, we're selecting, actually, we're comparing day and night in this instance, right? So daytime and nighttime samples and seeing how our model behaves with respect to those samples. So we see like raw, predictions. We see the model performance. And then if we actually scroll down, kind of the kicker is you can see that there's a tail or there's like a part of the nighttime performance that suggests that the model has like a failure mode, right? We have the confusion matrices with all the different classes in this automotive data set. Almost there. And again, here at the bottom right, we can see our confidence distribution is slightly different for nighttime versus daytime. And again, that's something we can start to look at. Maybe we need more balance, right? Maybe we need more nighttime samples. So again, the goal here is to start to, again, fine tune your data in terms of how you're analyzing it based off of attributes you select. All right. So where have we gone, right? What was our end-to-end loop? Ultimately, right, like I said before, kind of the theme we're going at is none of what's typically and often treated as like separate, kind of isolated pillars in the machine learning process really shouldn't be separated that way. Right? If anyone here has had like a software engineering background, that was my original life is like a kind of a pure software engineer. You're probably familiar with the idea of shift left and the DevOps revolution. The idea is that like having very, very long cycles where like you're handing off to completely isolated teams ultimately adds a lot of friction and doesn't result in higher quality kind of counterintuitively. Rather, having the team, sometimes the same people, work within this loop and be at least part of this loop, have hopefully kind of a consistent platform that allows you to do it, and ultimately creating workflows where like all stakeholders are fully looped into that workflow allows you to move faster and right come up with incremental model improvements, have a reasonable governance process to how unlabeled data becomes labeled data, then goes under review and correction, and then allows you to again, once you have your model finally trained and deployed, evaluate that model with respect to that data you annotated, and then again start off with one again as needed. All right. So ultimately, that is what I wanted to talk about today. Um, I can see there is quite a lot of chatter in the chat. I see Burhan did a great job addressing all of that. What I want to leave with is, first of all, thank you for your attendance. Couple ways you can get started. Again, this new release of 51 has quite a lot of the features I was talking about, mainly around the annotation workflow management front. If you've been using open source 51, you've probably noticed that the latest package has that annotate tab. It's 51 Enterprise that has a lot of these new kind of workflow management features. So if that's something that interests you, we encourage you to give us a ring or talk to us. I guess give us a form filled out. Go to voxel51.com/sales. There's a QR code here. Again, we do have the open source package as well. It's just installable through pip install 51. You can look at the docs for how to do that to get started with your own local annotation work as well.